Hey there! In this video, we're going to be taking a look at the basics of rocket propulsion. We'll try and answer the question of how a rocket actually moves up and away from the launch pad and into space. We'll look at the physics behind it and some of the hardware that actually makes it possible in real life. Before we get started, if you feel like you already know some of the information here, you can skip ahead in the video using the timestamps here and in the description. Now that that's out of the way, let's get spacey. The fundamental concept of rocket propulsion begins with an understanding of Newton's laws. These are three physical laws that have laid the foundation for studying modern physics. Starting with Newton's first law, which states, "A body at rest will remain at rest, and a body in motion will remain in motion unless it is acted upon by a force." Now, that's a long sentence, so let's simplify that. It essentially states that if an object is not moving, it will stay stationary unless it is affected by another force. And the same stands true for an object that is moving. It will continue to move unless affected by another force. Now, this force can be anything, including the force of gravity or the force of friction. This is why you may see a moving object stop after a while. It isn't defying Newton's first law of motion, since the force here is friction. Moving on to the second law of motion, it states, the force acting on an object is equal to the mass of that object times its acceleration, leading to the equation F is equal to ma. So we talked about an external force in the previous law, and this law defines the nature of that force. It indicates that the total force applied on an object will depend on two things: the mass of the object and the acceleration it needs. The equation F is equal to ma quantifies this force, with F being force, m being mass, and a being acceleration. Finally, Newton's third law of motion states, for every action, there is an equal and opposite reaction. This may seem very simple, but is the core principle of how rockets move. When a force is applied against an object in any direction, an equal force is applied back by the object in the opposite direction. Now that we understand what Newton's laws of motion are, let's see how that plays a role in rocket propulsion. Let's have a situation of a rocket sitting on a launch pad. It is stationary and remains so due to Newton's first law of motion. So we need another external force to push the rocket in this direction, which can be done using Newton's third law of motion by exerting a force in this direction, which will then in turn produce an equal force in the opposite direction, or in this case upwards. Now the strength of this force can be determined using the mass of the rocket and its required acceleration with the formula F is equal to ma from Newton's second law. This method of producing a force in the opposite direction using Newton's third law is what is known as thrust. In order to produce the thrust, we need some material that can be thrown out in this direction to produce the force in this direction. So, this is the basic principle behind the propulsion system used in rockets. We have a certain amount of material, and we push that material out at a certain speed, and that makes a rocket move upward or in the opposite direction. To produce thrust in such a way, rockets use engines. An engine is a machine that converts energy from its propellant into motion. Propellant is the material that is used by a rocket to produce thrust. There are many types of rocket engines and propellants, each with its own advantages and disadvantages. These are solid rocket motors, liquid rocket engines, hybrid engines, ion engines, and nuclear thermal engines. These will be discussed in detail in the next few videos. And that's rocket propulsion for you. It is quite simply using Newton's laws of motion to produce thrust by expelling certain propellant out of a rocket using engines. If you have any questions, feel free to post them down in the comments. Like and subscribe if you feel like it, and until next time, stay spacey.